I guess that's a good test of the microphone. All right, it's 1:30, a little bit after, so I guess we'll get started. The coveted right after lunch spot, so hopefully everybody's still energized, everybody's having a good conference so far. Really been impressed by the content I've heard. My name is Jonathan Janos. I'm a solutions architect at MapR. MapR plays in the Hadoop space, okay, which is, at this point, Hadoop is a multi-billion-dollar industry that's really been spawned by Google, right? This stuff all came out of Google. And so kind of appropriate to be talking about this at a Google kind of show. And what I'm going to talk to you about today is something called Apache Drill, which is a parallelized SQL query engine for big data, right? And it too has its roots in Google, right? So heard Jordan's talk this morning about Dremel and BigQuery. And so, this is just yet another example of how some great innovation from Google, right, was kind of publicized or made public. Hey, here's how we do things. And years later, right, it spawns a life of its own, right, and the rest of the world benefits, right, from some of the public, release of some information, right. And I was very gratified to hear earlier today that there's a reason for it, right. You get into the open source community, and then it spawns additional innovation, right. And so I think this is one of those cases, because it's very cool technology. Now it's a query engine, so I tried to figure out too this is a developer conference, right? We're developers. So I tried to kind of spin this to try to make this kind of relevant to developers. Why is this cool for developers? Because sometimes, this gets portrayed in the context of hooking it up to like BI tools, and that's certainly very good, but we're developers, right? So what do we want to do with a development tool? Yeah, go ahead. We got a question. Well, this was just a recently coined term by me just a little while ago. So you're the first to hear it. So, but it got you here, right? How many people, show of hands, how many people read the intro, the session intro and description? How many people read it? I got one. And a cautious hand. So I'm glad I didn't put too much time into that, because nobody reads it, so that's a good thing. How many are people here because the title sounded kind of interesting? All right, good data point. All right, put effort into your titles. And I knew I had to compete, and I thought this might be kind of interesting, but it is relevant too. So yeah. So what I mean by big JSON is JSON is a widely used, adopted storage format or data format, especially for developers. Developers love JSON, right? And so what I'm calling big JSON is just the fact that, well, hey, this is a big data processing engine, and it works with really, really big data sets of JSON data too, which is kind of unique in the industry. And I thought that would be a pretty good topic for you guys here, right? So that's kind of what we're going to talk about, all right? And we're going to talk about that use case. So I'm going to wrap that up into a use case that can be relevant for developers, right? Because developers consume a lot of JSON. And if I had my way based on this talk, I think you might be encouraged to actually produce more JSON now that you can do this stuff with it, right? So with that being said, here are the goals for this session, right? We are here on Friday. We're going to learn about it. Apache Drill, be exposed to that technology, right? I want to expose you to it. I'm going to give you guys the weekend off, right? In case you want to be well-rounded, right? Or maybe get exercise, right? But then come Monday, right? The goal is I'm going to get you guys up and using Apache Drill, right? I'm going to show you kind of how easy it is to do. I'm going to wrap it up into a use case that, again, as developers, I think you might find appealing, right? So that's the goal. All right, so what is Apache Drill? Start with that. Drill is a distributed SQL engine for big data, okay? So here's kind of the notion, right? It runs on a cluster. So again, this technology is kind of born out of Hadoop, right? So a lot of the stuff you're going to see is Hadoop-centric, but it doesn't have to be. It's not really dependent on Hadoop at all. But the notion is, right, you have a bunch of machines here, right? Data is going to be distributed across those machines. Again, it doesn't have to be, but it helps because we're going to have these services, these drill services running on each of these machines in a cluster, right? Those things are going to be called drill bits, okay? And that's really all it needs. It doesn't really need anything else. We've got Zookeeper over there on the right, another kind of common component that's going to keep track of where all the drill bits are, so they know how to talk to each other, okay? And that's really it. It's a pretty simple kind of architecture, right? And the idea is you're going to submit a query. A client submits a query. It can submit it. There's no concept of like a master service or slave services here. A client can submit that query to any one of these drill bits, right? And it's going to know that from the Zookeeper information. And each drill bit is going to know what its peers are, again, based on information in drill bit. So one of these drill bits gets that query, right? And it is going to parse that query, and then is going to come up with an execution plan. And that's a phrase borrowed from standard database technology, right? That's been going on for years, but it comes up with an execution plan that's going to incorporate optimizations, right? It's going to incorporate data locality, right? So that's why it's nice if the drill bits reside on the same servers or nodes as your data, right? Because it's going to incorporate that data locality so that each drill bit or process can process data that's local to it, right? It's going to come up with this execution plan. It's going to break up that query into fragments. It's going to send out those fragments to each of these different nodes. Each node is going to work ahead on its little piece, right, of that query, come back with the results, and it consolidates the results and sends it back to the client, right? That's kind of the notion. Built for the big scale, but also so simple enough, right, architecture, that it also runs on your desktop, right? Which is something I want to point out, because again, it makes it much easier for you guys to be up and running with this stuff. You don't need a whole cluster to be up and running with you. It'll run on your desktop, okay? So it runs on your desktop, works at big scale. I'm going to skip past this. This is what I just talked about. Okay. There are lots to talk about drill. I think it's really some sweet technology that's out there. But I like to focus on some top-level things. These are three what I think are really fantastic characteristics of drill. And by the way, there are a lot of other big data like query engines that are out there too. They all have their sweet spots, right? So these are three things that I think make drill really great. Number one, it is AntiStandard Sequel, which is pretty nice, right? Which to me means throw away the user guide, right? What self-respecting developer reads user guides, right? This means it's just much easier to use and operate with, right? If you have a SQL background, as I did, I came back from the database world, right? Started working through some of the tutorials early on. And after a while, after a couple of iterations, if you know SQL, I'm like, wait a minute, I can do this. I already know this, right? And I wonder if it does this, I wonder if it does that, right? Back to my old query days, and it works. It all works, right? AntiStandard Sequel, so this is a design goal of it from the beginning, okay? This is an example, right, of the kinds of queries, kind of complex queries, and it gets much more complex than this, right? Standard SQL, all right? Much easier to learn and much more interoperable with some other tools that are out there. Number two, it transcends the data store. So I mentioned before that was kind of born of Hadoop, so you'll see this slide is a pretty heavy Hadoop focus. But it's designed with like a plug-in data architecture, modular, right? Plugins. And so you can say, hey, here's where the data's coming from, and you kind of plug it into the framework, and it can pull data from that, and it can query it, and it can join the data coming across from these different sources. So here's like an example, and this isn't even a complete list, but we can start with the Hadoop distributed file system, right? You can put data in a distributed file system and put drill on top of that, and it can pull that data. Inside of Hadoop, you can have like H-based data, right? We can pull data from that. We've got Hive. It can pull, if you've got a Hive data source, you can just pull data from that, and it can leverage the schema definitions that are already there. MapR is kind of in that same ballpark, because MapR is kind of like genetically re-engineered Hadoop, and so we have equivalent components there, like the MapR file system and something we call MapRDB. Or maybe you guys are running Mongo. Well, there's a plugin for Mongo, which is kind of cool, which means you can run drill on a Mongo cluster or combine data from Mongo with other sources, right? If you're running in the cloud, you can pull data from S3. You can pull data from Google Cloud Storage, right? And you can combine data from these different sources.
So are these data still have to be JSON?
No, it doesn't. JSON, I'm just choosing to focus on JSON in this case, but no, it doesn't. It supports all sorts of different file formats, so or data formats. So, for example, it supports CSV files, right? It supports data that's stored in HBase. So right here, you'll notice, that's noticeably absent right here, right? Is traditional relational database stores, right? They're not here in the mix. The initial kind of focus area has almost entirely been NoSQL data stores, but there's a lot of interest in that. And as I mentioned, the plugin framework is modular, and so there are people working on just that, right? Coming in with a plugin for an RDBMS data store that would satisfy something like MySQL. And by the way, you guys are developers. There's an API to build plugins. So if there's a data store that you guys want, right, you could be the guy to do that, all right? And this, by the way, I should mention too, Drill is open source, right? So it was incubated at MapR, but at this point it's a top-level Apache project and managed as such, okay? But yeah, so right now that has not been the emphasis so far, is to reach into RDBMS systems, is more for the NoSQL world, right? So to take another view of this, it shows the information in a slightly different way, right? This is kind of the simplified picture that we're looking at. You have data in multiple different data stores, right? You may or may not have some of this stuff, right? I've got Hive there, I've got HBase, but everybody's got files. Everybody's got directories, right? Drill kind of can sit on top of all of that stuff, combine data from all those different sources in different formats, and we're going to get into some of that. And then on top of that too, so we've got ODBC drivers for Drill and JDBC drivers for Drill, right? And that lets it hook into some existing BI tools or custom apps that you guys could build as well. And because it's standard SQL, there's a lot of interoperability there, okay? So that's really nice. But where I'm going to focus on here on this talk, and by the way, there's tons of information out on this. I'm really impressed, actually, with the documentation. Sometimes new product comes to market, the documentation can be dodgy, right? Lots of really good information out there. But I'm going to focus on the JSON part today, right? Because you guys probably already have a lot of JSON data, right, that you're working with. That's just sitting out there in files. So again, I'm focusing on the low overhead, right? If you've got JSON data in files, you can use Drill on it. Fantastic thing number 3. So no, it doesn't have to be JSON, but it's really cool against JSON because it supports JSON out of the box natively, right? And it discovers the schema of this data on the fly. So you don't have to register anywhere a schema definition, right? You don't have to say, hey, Drill, these are the columns in my table. These are the types. You don't have to do that. You just point it to the data and you query it. And you'll run a query and you'll say, hey, show me all the data that, I'm looking for males in area code 206. Show me everything that comes back. And it will discover the schema within that data, using the self-describing data that's format that's there, right? So if it doesn't have this particular attribute on it, if a particular record doesn't have that, Drill won't care. It just won't return the record. It doesn't satisfy the query. That's fine, right? And if it does match, it'll return the query, right? So this is pretty cool, right? So what this lets you do, right, is this lets you kind of send queries or start querying data that is, first of all, nested, right? It supports full nested JSON. It doesn't require any kind of external metadata repository, right? And it also supports evolving data schemas, right? So if this is what the data looks like today, but later on the attributes change, that's okay too. Drill kind of supports that without any additional work on your part. So this is kind of in contrast to like previous RDBMS worlds, right? Where if you wanted to modify your schema, right, as a developer, right, if you wanted to add a new attribute, that can be kind of painful, right? It just adds more steps to the process. You might have to get the DBA involved. You got to change the schema of the database, right? You may have to change your code. Here it kind of short circuits that whole process. Pretty cool. So if we look at the type of data, I thought this was kind of interesting because it kind of shows you, what the different data formats are kind of good for. But on this axis here, we've got flat data versus complex data, right? Nested data. So here we could have, for example, CSV files, tab-separated files. You've got other file storage formats. That, again, everything has its sweet spot, right? And it's optimized for different reasons, but this lets you have kind of complex data types, but the schema is still fixed. Going over from left to right, you've got some more kind of flexibility too, where, hey, here's your fixed schema, but as you go to the right, there are technologies that allow you to kind of change that data structure as you go. And what's nice about Drill is that it plays with all these types of data equally well, right? Because once you can handle this type, you pretty much get the others for free. All right, so a little more background, a little more information before we get to the kind of the use case kind of want to say. So more about our modular storage plugin architecture, that is Drill, right? So out of the box, you're going to get certain plugins, right? And more can be added. So each of these plugins will have a certain configuration that you kind of point to. Again, their defaults are kind of set out of the box, but a couple things I'll point your attention to. One of the plugins is a DFS, distributed file store. And then look over there, it's got something called workspaces, right? Defines different workspaces for you, like root or temp. Basically, that's just like a shortcut into a particular path in your file system. That's all. But I bring it up because you're going to see it in the queries, right? So you can see the structure. And then another thing on the right, you see where the JSON data type is defined. You'll see things like CSV types defined. So a JSON file type is defined, right, in the DFS plugin, right? That's kind of what we're showing. And then you'll see other plugins over here, right, that might have their own configuration information, right, how to connect, how to reference data in that store. CP is class path, right? So class path just for maintaining various classes, Java code that's kind of stored in the system. Yeah. Yep. Okay. And so what that kind of enables, the idea, the concept, right, the Holy Grail, is SQL on everything, right? Whatever your data looks like, you can run SQL on it. And this is kind of what that SQL structure would look like. Do a select star from, okay, the stuff in blue, that's your storage plugin. Hey, I'm pulling this from the distributed file storage. Maybe it wouldn't be that. Maybe it would be MapRDB or Mongo, right? That's where that would show up. And traditional dot notation, right, which is kind of nice. So I want to look at my distributed file system. Within that, I've got a workspace called Yelp, so that's going to point me to a specific spot, right, in that file system. Or if I was looking at a Hive database or an HBase database, it might point me to a particular database, right? And then underneath that, for file stores, right, the stuff in yellow would be pointing me to either a specific file name or a specific directory of files that I want to process, right? And it's just a consistent format regardless of what your underlying data store is. And on the file system, what you can do is pretty cool as far as how you can process that. So you can query individual files, or you can do entire directory trees. And this stuff is pretty readable, right? So on the top one, we're doing a select, right? And we're pointing to a file store, so, some workspace called logs. And within that, right, and this gets back to the question of what the file format has to be. You see that's not JSON. That's on the top example, we're using a Parquet file. And we're going to be grouping that information by error level, okay? Down below, what I'm doing is I'm not specifying a specific file. I'm specifying a directory, right? And it's going to go and query all the files in that directory or subdirectories as if it's a single entity. Okay? Combine the data sources on the fly. So here's an example of we're taking some directory of log information and we're combining it with a JSON file to compile that information together and do some analysis, right? Same thing below. Here on below, we're joining stuff from a Hive table and an HBase table, right? But it's all consistent, right? You're just, at this point, just joining things based on attributes. What's cool is that underneath the hood, right, they're entirely different storage platforms, right, to do this. And that's a pretty real-world situation, right? Because how often is all your data stored in one place, right? So very, very, very useful. We're going to blow through some of these examples pretty quickly, just because I want you to get, again, more familiarity with it, right? So just standard dot notation to drill down into nested data here, okay? So if things are nested, you just add a dot to it, right? And you can traverse down the data structure, right? And you include that directly into your SQL. But other than that, the SQL is all just regular standard stuff, right? So the only thing that's really changing here is the dot notation. And then when you kind of get this query results back here, Drill is nice enough to kind of flatten that information and put it on a single record file for you. Views I want to add here, because views are pretty convenient, and they perform a lot of different functions here. One, though, is to traverse down that data path kind of gets to be a hassle after a while. So it's nice to be able to create a view that kind of just does that flattening for you, makes it much more productive to work with going forward. But another reason I want to bring up views is because this is where kind of security control and access control can come into play too, because this view becomes a security mechanism. And it does it in what I think is a very, very cool, interesting way. When you create a view here, that view is stored itself as a file, not the data. It doesn't repeat. It doesn't regenerate the data. It's just the query, and that query is stored as a file. And once it's stored as a file, what we can do is we can control access to that file, right? Pretty fine-grained access to that file. And so we can say, hey, I'm not going to give you actually any raw access to the raw data, right? I'm going to protect all that, but I will give you access to this, which is essentially a subset of the data, right? Because this query can define restricted rows, restricted columns of the data that you are entitled to, right? So just say you're in the HR department, right? You could say, hey, select star from something where the department is HR, right? That's the data you have access to. So views come in really helpful for that too, for introducing some access control. Materialized views. See, all these concepts are just kind of borrowed from traditional kind of database worlds, right? So here too, we can just create a materialized view, right? This is actually going to create another physical data set, right, in your store, right? Here, what we're doing up top, we're setting the file format. So what this comes in pretty useful is you can use this to change file formats, right? Your data exists in JSON. You can rewrite it very, very easily into some other file storage format, which in the Hadoop world now is pretty common because a lot of times you want to store data differently to optimize for different things, right? You might want to optimize it for easy queryability. That's one format, but later on you may not want to do that. You pick a different storage format if you want to optimize for space on disk, right? And at the scale of big data, these kind of decisions are important. Okay, so now I want to kind of wrap all that stuff up into what I think is a really kind of interesting use case, right? What I want you guys to kind of think about for Monday. All right. So a great use case for this, right, is all your system logging. And by the way, this is not some esoteric use case. This is something you guys are already doing already, every day, right? This is an everyday use case. System logging, system auditing, right? Well, one thing I might advocate, and MapR is doing this, is you switch that information to be JSON, right? Start doing all your logging in JSON. And why would you want to do that, right? Well, here's a couple reasons why I think make it pretty compelling. One, it's pretty easy to do, right? It's take your current logger, right, and instead just start writing it as JSON. And you can just start drill up on your desktop, right? Again, you don't have to have a big infrastructure, just whatever system you're using. Start it, or if you've got a server, development server, just put drill on it. You're good to go. You can stick with files. There's no database involved. You don't have to set up a database, right? No need. So really lightweight. And then you can instantly query and analyze this data, right? Which is fine at the small scale, but going forward too, again, you guys are Google developers. Your apps are going to be huge, right? You're going to have tons of users. You're going to need to maintain that, though, and that's going to get complex. So after a while, you know, if user 217 clicks a button and it blows up, you're going to want to know what happened, right? So that's going to kind of generate some big data. So for ongoing system maintenance and troubleshooting and stuff like that, this is going to be really useful to know that you're using this kind of technology that's going to scale. It's going to support that kind of analysis, right? So you can seamlessly scale to big data. I'm going to show you how to do that. JSON is very, very dynamic. You can just add attributes at will, right? Really good for like system testing or user testing, right? A/B testing, right? You want to just say, hey, I'm going to add some new attribute to see what happens, right? You can just do that, and the system will pick it up. No additional overhead. Beautiful. And then if you want to be really fancy, you can then attach it to higher level reporting systems or BI dashboards or anything that you want because it supports those kind of mechanisms, right? So I guess what I'm advocating here is from day one with really very little effort, right, you can have what I would call enterprise class system maintenance and security auditing from day one, which is kind of nice if you're going to market. So if you're going in front of a customer, right, security is on everybody's mind these days. Isn't it nice to be able to go in from day one and say, oh yeah, by the way, we have yeah, enterprise class system auditing, because I log all my stuff in JSON, and I have instant queryability on it, instant access, instant reporting on it. And you can do all that from day one rather than as a bolt-on, right? Just do it now. All you got to do is log that data, and you've got a solution that's going to scale. So this is the use case I'm going to walk through. So you want to get it set up on your development box, right? 2 seconds, right? All you got to do is untar it, and you're installed. You're good to go, right? If you want to attach, right, you're just going to run the command line tool is called SQL line. So you run it, and you give it the -u fooled me. It's not user, it's the URL, okay? So you're putting that in, and you're saying you're going to specify the zookeeper location, which in this case is just going to be local, embedded, good to go. And then you can immediately start kind of querying data. Now, there's a little, one step is missing, right, which is the part where you configure, like, where does reviews sit on your file system. That's the only thing you'd have to configure. But other than that, if you've got log data that's out there, you can instantly start querying it, right? That's it. You're up and running. Here are some examples, right, of the kinds of analysis, right, in this use case of what you could do, right? So you could say, hey, how many errors did I have, right? Information, warning, error, per level, right, in January of 2014, right? So you just say, oh, go traverse this tree. I've got my logs split out, right? I got my logs sitting in a JSON file. I'm querying a single file, right, for that information. But it doesn't have to be that. You could say, hey, across all my applications, how many errors were generated, right? You could do that. Just specify here in the middle one. Just specify your directory right there, right? Another great use case. Or you could say, let's separate it by month. And this is pretty cool because what Jill can do is it tokenizes the path in the file system, and you can use that within your queries as like filter attributes, right? So this is saying, hey, do a select from this directory of my application logs, but I only want to see things after 2012. And the idea there is that, that would be the high-level directory, right? So it's comparing the actual structure of your file system, and it's incorporating that into your SQL statement, which is pretty cool. So you can say, hey, just show me everything after 2012, and let me group it by, and again, you can go down the directory tree as well. So directories 2 here would correspond in that example to the month, right? So you could say, oh, show me everything after 2012 and group it by month. How many errors did I see in my system in the month of whatever, right? Pretty good use case. Now, suppose you want to kind of scale that, right? Because again, on your desktop is one thing, but now you're successful, right? Now you got a lot of users, you got a lot of systems, right? What do you do? Well, the idea is the same thing that works on your desktop also works on a big cluster of machines, right? So if you have Drill already up and running there, that's great. We saw how easy it was. It's just as easy to install it on a cluster. But if you already have a cluster, the only thing that has to change in this environment is instead of writing your data to here, right, you're going to write it to the cluster instead. And that's easy enough to do. And this is one of the nice things about MapR that makes it really easy, because MapR has something called, we really support NFS for both reading and writing. And so with MapR, if you want to write it to a MapR cluster, the only thing you have to change is in your application, say, hey, don't write it to the C drive anymore. I'm going to mount the drive to my cluster. It's going to be completely transparent. I called it the M drive, but you call it anything you want. And all you have to do is, so you make this a configuration value on your application, right? And instead of writing it to your local C drive now, you're writing it to the cluster. Now you can support as much data as you want, right, on your cluster. And the same query system is already out there up and running. All right, so seamlessly scale, right? Start out with your desktop, your server on Monday, but if you want to deploy to a cluster, all you got to do is change the location of your log files. The query engine works. And then if you want to get into agile development, right, this too is where JSON really, really sings, because you can add custom attributes as you go, right, for whatever the use case is, and you can instantly start querying that, right? So here'd be like an example, right? Hey, I want to test how many people I redesign my UI. Let's see what kind of impact that has, right? So let me redesign my UI. I'm going to add a new button, right? I want people to click. I want to know whether somebody clicks on one button versus another, because I want to see which one is more appealing to them, right? Well, so to do that, and you're going to want to analyze that information afterwards, right? All you got to do is add in a new attribute. Hey, I got a new attribute. Call it whatever you want. A/B test, right? 1, 2, 3, right? This is what he clicked on. See, my point is that these things can be arbitrary, right? and they can be case specific, right? So you have a single test that you want to run, and that test is only going to run 2 weeks long. That's fine. So you just record that information, and later on, there's no schema change, right? You don't have to make that change anywhere else in your system. You're just going to, when you want to get that information, when you want to pull it back, you just do a select from, right? And you say, hey, show me everything in my user logs where I'm looking for something called A/B test. Show me what the results were, right? Instant access, instant visibility. If you want to get fancy, right? That's enough. But if you want to go to your customers and say, yeah, we built this entire system, right? You could totally fool them, right? Because it could look like you did a lot of work and you really did very little, which is fantastic. That's what I do all the time. So you can take the drill ODBC drivers or JDBC drivers, and again, either build a more formalized custom reporting mechanism on top of that, because maybe your customers might want to see that. Show me what you're doing for security auditing. Oh, well, let me show you. I just built this nice little report page for you. Well, all it's doing is generating SQL statements. That's all it's doing, right? Or if you want, you can just hook it up. Maybe they already have a tool, right? So here's Tableau, right? But there are others abound too, right? So you can just overlay one of these tools, use JDBC to connect, right, to drill, and drill becomes the data service provider. Again, from stuff that's in Hadoop, but also it could be stuff that's stored elsewhere as well, right? And then finally, kind of the last kind of piece to think about of how you might be able to use this in that system is you might have additional considerations, right? Like long-term data storage, right? So you've got all these log files. How long do you keep them? Now you're generating a lot of data, right? You may not want to keep it in JSON over the long term because JSON is not really an efficient data storage format. It's really, it's really useful for flexibility because you can add in new attributes and it's really good for flexibility. But it may not be the best case to actually store that data for long term, especially if you've got really large data sets, right? So here I can use, another example of how I can use drill just to kind of change the format of my data, right, from JSON to something else that might be more efficient in terms of space consumed on disk, right? So for example, I could choose something like Parquet here. It's going to do that conversion in terms of coding, right? So you'll see immediate benefits in terms of how much space is being used. Here also you may want to maybe reorder your data because there too, if you reorder the data based on certain values, you might see additional compression benefits, right? And so you can do all that within drill, right? Yeah.
In this case here, is this like a standing query or is this a shot in time? I'm going to take whatever is in this table that I'm creating, using to populate this other table at that point in time, or will it keep going as I add new data?
No, it's former, latter. It's a single shot in time, right? You're going to query this. It's going to say it's going to take everything there. And it's going to create a new data set based on what was there. Yep.
So if I add to that old data set, it won't then.
No, it's not continually running. You could always, of course, just adjust this, use like a timestamp or something like that, or a counter, and say, give me. You'd have to build that into it. Exactly. Yeah, there's no built-in kind of synchronization or real-time updating kind of capability in that. Yep, you got it.
I see this very similar to the materialized view that you mentioned earlier. So materialized view is also a one-time generation?
Yes, that's right.
It's not actually a view.
It really is. You can compare it to like relational database world. Yeah, you're right. That's right. It's here, yeah, materialized view is being used to say it's just a one-shot snapshot. It's more like a snapshot of the table. Yeah, it's not like a database materialized view where it's keeping track and constantly re-updating that information. So you're right. That's a good distinction. And as I mentioned, this is kind of this is the direction that MapR is heading too, right? So we are using now JSON. We have switched to JSON for these purposes. So for system logging and system auditing, yeah, we've switched over to JSON, right? And it's because of things like this, because we get instant queryability and analysis of it, right? So, in our 5.0 release, right, we've introduced system auditing, and this is kind of the format, what it looks like, right? So this is like a flat JSON record. And these are the fields we're capturing, but we get instant queryability of that data, right? So it's a really kind of compelling use case. MapR has really kind of gotten all in on it. And it's because you have that queryability, right, of that data, right? So again, I want to emphasize JSON is not the only format that's supported here. It's really any kind of format. But JSON from a developer point of view is really kind of compelling, right? And it kind of, as a developer, you can kind of use this to kind of work with the data sets that you're currently working with on a daily basis, right? This here is, we have auditing features, which means that when you perform certain actions within MapR, we write that information to a log file, right? We are writing that information. MapR is kind of switched to a JSON data format for that kind of thing. The reason we have switched to that JSON formatting, right, there are all the benefits that go with JSON as far as readability, as far as flexibility, right, schema flexibility. But we wouldn't have done that without having a query tool, right, that makes that data really accessible. We wouldn't have done that, right? So now that we have this query engine, right, that supports this JSON format natively and makes it really, really easy to work with, we're switching a lot of our internal functions, right? And that's kind of what I'm kind of pitching to you guys, right? To see if that's kind of compelling. But it's the same thing, right? Take some of your internal mechanisms, right, and switch it over to JSON format, because now you have a tool, right, that's going to be there to kind of query and analyze that stuff out of the box. You still have to build in that auditing feature, right? This data doesn't appear magically, right, in your code, right? You would have to build in the code, right, to say, hey, the user clicked on this button, I want to record that feature, right? Well, what I'm saying is you could record that action in any format you wanted, right? I think there are a lot of benefits now to recording it as a JSON object. Yeah. Make sense? Yeah.
Does the JSON have to be a flat, attribute value here like this, or does it support nested out?
Yeah, so no, it doesn't. No, this is flat. This is flat. But back to the beginning, right? Remember I pointed to the dot notation? No, it's fully complex, nested data, arrays. Yeah, full JSON support. It does not do XML. No, it does not do XML. If you talk to, it's funny too, the perspective coming from like Silicon Valley is like XML is dead, a dead format, It's all about JSON. So I have detected, what do I know? But I've detected very little interest in kind of pursuing kind of XML type formats, right? So it doesn't do that. But that being said, there's really no reason it can. But the approach you'd have to use now is kind of convert that XML stuff to JSON, right? Yep. And then the other formats that you mentioned as well. That's where I don't know, if there was ever such a thing as sexy data formats, right? It's all about JSON now, Avro, Parquet, and some of the new file formats that are coming out. There's been very little interest that I've detected on the XML front, which in one sense is a shame because a lot of people still use a lot of XML, especially. Absolutely, there is. Yeah. So this won't be able to query that XML out of the box. Really, you have to convert JSON. Yep. Exactly right. So I encourage you guys to go. You can grab this deck. It's online. This is a great jumping off point for drill. There's tons of information that's out there. You can get to my presentation is out there. I encourage you guys to give feedback too. Would welcome your feedback. But there are demo videos that are out there. You can pull down a free sandbox, right? There's tons of free online training. There's free online training for drill too, actually, which is really well done. So tons of good information that's out there. Yeah. And it's just at eventsmapr.com, DevFestDC, all right? What do you guys think? You guys want to go and check it out on Monday? All right. I'll accept 90% buy-in is what I was looking for. I think I got it. Yeah.
So what about synchronization between the three bits or something? There's no synchronization between those? Or?
Yeah, there is synchronization between those. Yes, there is. Yep. So those processes communicate as they need to in order to aggregate the data and consolidate it. And also metadata is exchanged between the drill bits as well, right? And for that, there's distributed caching kind of technology that's in there too. Well, the scalability. This will scale to petabytes, right? That's the number I've heard, right? I don't have formal numbers for you to kind of look at that, right? But yeah, it's probably petabyte scale. It's pretty big. It's all relative these days. I don't know. Is that big? I don't know. I saw the Google numbers coming out. It's, that's like was collected in the time of this talk, right? Another petabyte of information was just collected.
We have select statements. What about other things like insert, delete, update? Do you have them?
Mostly it's just for selecting and querying analysis. Yeah, it's still not. I sense that your background is more on the relational side because you ask questions about MySQL, right? Plugging into those data stores. Yeah, this is still very much in the analytical side of the house, right? And so Yeah, it's not really geared towards just inserts. For that, there are other technologies that are out there, right, to get inserts into the data. I'm not sure what value Drill would add in terms of inserting data, because that capability is already there, right? You can already insert information.
Because I want to know that record, I only materialize and I never want to come back to it.
Yeah,
Things like that.
right.
So update it as I read it.
Yeah. Yeah, no, for now, right now, yeah, the answer is no. It's more select-oriented or creating tables. Yep, modifying table structures. Yeah. Incorporating user-defined functions? I don't believe so. Eric, do you know, do we do UDFs in here? You can. Oh, yeah. Yeah. Okay, so the question is, what other formats can be, how do you support formats that are not in the traditional formats such as CSV? Yeah. So, yeah, if it's a raw log file, as long as a standard, that still falls into the standard formatting in terms of comma-separated values or straight text, right? It gets a little tricky, maybe like XML might be an example, right, of some kind of new, different file format that's not quite supported. Yeah, so for doing that, you'd have to write into the API additional plugin that kind of supports, yeah, that kind of capability, a modification. I haven't seen the API. Is it Java written or is it or C? Yeah. Another question back. Okay, the question was compare drill to Impala. So Impala is another, I should stay away from that speaker. Impala is another kind of query engine, right, that's built for big data situations. It's also kind of born out of Hadoop, so it plays with Hadoop. Let's do a comparison. Is it one for one? No, I wouldn't say it's one for one. I'd say again, the different tools have their different sweet spots. Impala, I think, is really optimized to run against, say, Parquet file formats. I think it's really good in case you have recurring queries that you're running over and over and over again. I think from that point of view, I think Impala will probably run faster than Drill will. Drill, you kind of sacrifice some of that raw speed for the flexibility it gets you, right? I would say there are other differences as well, but to me, that's the biggest difference, is that we're kind of emphasizing on-the-fly discovery, right? Which has benefits in terms of kind of shortening the process and the overhead of what you have to do to prepare that data. As soon as that data lands, you're good to go, right? And that data can change over time. Also, that pluggable architecture, I think, is pretty notable, that you can incorporate data from non-Hadoop sources. That's kind of pretty key as well. If you get down to the raw speed, though, hey, this is what my data looks like. It's a static format, and this is what we run all the time. That might be a case where, you know, Impala might be a better fit for that particular use case, right? So no, I wouldn't say it's one-to-one. I would say the different tools have their different sweet spots. Yes? There is currently not, but there's an HBase play and there's a MapR DB play, which are both the same technologies, right? The question was about Accumulo, which is kind of another variation, I would say, of those things. So I don't know if that would require additional adaptation to kind of support a cumulo, but that was something we could definitely kind of follow up on and kind of look into to see what would make that happen. Wrapping up? Okay, guys. Okay. Public service announcement. Somebody left their phone over there. Thanks, guys, for your time. Again, I encourage you to check out the URL. Thank you.